Okay, here's our video on data variability. And now we know what data is. Data is just information or numbers. And variability is how those numbers differ from each other. So we'll go over that. So when we do data variability, we do box and whisker plots. That's one thing we can do. And we did box and whisker plots in 6th grade. So we'll just call them box plots. And the first thing is you look at the data, these numbers, and we want to make sure that they're in order, and they're in order already. So the next thing we want to do is we want to find the median. So we want to find the median. And the median is the middle number. So what do you think is the median in this dot plot? In this box plot, I mean. Well, if we look, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers, so we're going to have 2 numbers that are in the median. So these 2 numbers, 3 and 4, are in the middle. So we want to know what is the median of these 2 numbers. Well, if we take these 2 numbers and add them, we get 7, and we divide it by 2, we're going to get 3.5. So 3.5 is the median. Now when we do data variability, the median is also called Q2. So just remember that. Q2 is the median. Now the next thing we want to find is what we call Q1, or the lower quartile. And the lower quartile is the median of the numbers to the left of the median. Sounds strange, right? So the numbers to the left of 3.5 are all these numbers I circled. And we want to find the median of those numbers. That'll be Q1, or the lower quartile. So again, the numbers to the left of 3.5, let's fix that, and we want to find the next median. So we have 4 numbers here, and 3's in the middle. So the lower quartile would be 3, or Q1. We also want to find now Q3. Q3 is the upper quartile. Now the upper quartile is the median of the numbers to the right of the median. So again, the median was 3.5, and these numbers are to the right. And we want to find what is the median of those numbers. So 6 and 8 are in the middle. You have to add 6 and 8, divide by 2, and the upper quartile will be 7. So now we have Q1, Q2, and Q3. Now you should rewind the tape if you didn't understand that. Now, we also want to know what is our least value. Well, that one's easy. We don't have to do any arithmetic. 2. 2 is our least value, and 12 is our greatest value. So now we can make a box plot. Okay, so we'll make a number line. First thing we want to do, try to make it as straight as you can. And we can put in numbers from 1 to 12, or 1 to 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's fine, just number them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so our least value, remember when we did the box plot, 2 was our least value. So we're going to put a dot by 2, and that's the beginning of the whisker. And we're going to go all the way to, we find Q1, which was the lower quartile, and it was 3. So we're going to stop at 3. The whisker stops at 3, and we make a line there because we're going to create a box. And that's Q1, or the lower quartile. This is our least value, which is the minimum, or the min. Now we want to find Q2. Remember, the Q2 was the median. It was 3.5, so we'll just go to 3.5 and right there, and we have now our part of the box already, and that's Q2, which is the median. And now we want to go to Q3. Q3 is the upper quartile, which was 7. So we'll draw a line all the way to 7. And now we finished our box on 7. And that's Q3. And to finish it off, we need to go to the maximum value, the greatest value, which was 12. So we'll make a line all the way to 12 and put our dot. So now we made our box and whisker, or just our box plot. We have Q2, which is the median. Q1 was the lower quartile, Q3 was the upper quartile, and then we have our minimum and we have our max, or maximum. We have our least value and our greatest value, and that's our box plot. Now we need to know a term called the interquartile range. The interquartile range, and it's abbreviated as IQR. So you'll see this a lot in textbooks and on the test. So it's called IQR, and it's the interquartile range. And it's not too difficult. All you do is, it's Q3 minus Q1. That gives you the interquartile range. So let's look. That's Q3, 7. Q1 is 3. 7 minus 3 is 4. So the interquartile range of the data we had is 4. Okay, our next vocabulary word is the mean absolute deviation, or MAD. And to get the mean absolute deviation, or MAD, we need to find the mean. So let's find the MAD. Okay, well, if we add the sum, we'll get 57. And there's 8 values. So 57 divided by 8 is 7, so the mean is 7. So we're almost there. The mean is 7. Now we need to find the mean absolute deviation, or MAD. Now the MAD, or the mean absolute deviation, is the distance that each point, each value that we have, is from the mean. How far is 3 from the mean? So again, the mean is 7. We know the mean is 7. So how far is 3 from the mean? It's 4. It's 4 away from 7. 5 is 2 away. 6, 1 away. We have another 6. It's 1 away. 8 is also 1 away. 8 is 1 away. 9 is 2 away. And 12 is 4 away. 5 away. So this is the distance we have that these values are from the mean. Now what do? We're going to add all these together, add the sum of all the numbers that are the distance away, and we'll get the mean of that, and that's the MAD. So find the sum and get the MAD. Okay, so again, get the MAD, not get mad. So if we add all this together, we're going to have 17. And 17 divided by 8 will give us 2.125. So 2.125 is the mean absolute deviation, or the MAD. Okay, so we went over how to make a box plot, how to get the interquartile range, and how to get the MAD. Great job.